Hello and welcome to For the Love of Nature, a podcast where we tell you everything you need to know about nature and probably more than you wanted to know. I'm Laura Fawks Lapole.
And I'm Katy Holloway, and today we're talking about fossils.
Ooh.
Nature news first?
Yeah.
Because I'm excited to get into the fossils.
Yeah, for sure.
It is
real quick.
Real quick nature news. I was going to say, because this episode, it's not dense, it's fossils, and so it's really interesting, so we're going to try to make it...
Yeah, it's like technical and also like, whoa.
Yeah, I promise you, we will tell you mind-blowing facts today.
I agree. I think I can almost guarantee that. Okay, well, my nature news, real quick, it's, I've done dinosaurs and fossils for all my nature news, but I'm not doing it for fossils.
The one episode.
Back in March... this article says researchers name newly discovered insects after legendary Pokemon.
Oh.
Yeah, so two
why not? Why not?
No, right, you can name it whatever you want. So two entomologists decided to name their recently discovered new species of Australian beetles. Binburum, that's like their genus. All of them are Binburum. Okay. There's Binburum articuno, Binburum multres, and Binburum zapdos. So... all three legendary Pokemon are now true things. They're just not Pokemon, they're beetles.
I wonder if kids are going to try to catch them all now.
In Australia, I'd be scared. Yeah. Is this Articuno?
Yeah.
No, oh gosh!
That's fun, though. That's fun. And I remember whenever the Pokemon Go stuff started coming out, they did, like, a lot of zoos, museums really hopped on trying to put some science around it. So that's really fun.
Yeah.
All right, ready for my nature news?
Sure.
It's finally happening. All right, so the alien reports were released.
Oh, thank goodness.
Yes, all right. But...
I've seen some hokey stuff.
Yeah, but we've had no explanation. So that's the government's official stance. So Katy's middle school X-File loving self was really waiting for some doozies. But there are, and I think we've talked about this, not on the podcast, but I think outside of the podcast, that there are people, especially on Reddit, that sleuth through, the released CIA files and things like that, that have been declassified. And so I'm really excited to see, as those guys are sleuthing through more than information. But, so for those of you who don't know, and we've definitely talked about this before on the podcast, but... they were going to be releasing, the government, when I say they would put together a task force to look into and to officially release any of the military's reports on whether aliens exist. So that was finally released on Friday, end of June-ish.
Yeah.
And it basically, out of the 143 official reports since 2004... that have remained unexplained. The document that was released Friday by the Office of the Director of National Intelligence said of those 21 reports of unknown phenomenon involving 18 episodes possibly demonstrate technological capabilities that are unknown to the United States.
That's what I heard that they said too.
And
it's basically just a cop-out of being like, could be.
Yeah, they took...
don't know.
Yeah, they don't want to take a hard stance and collapse our economy, so they're just taking the, I don't know.
It could be the Russians, could be aliens.
Well, they did, they all did agree that they do not believe that it's Russia or China, just because of the I think, there were some very specific cases where they say, the rapid acceleration... just the propulsion rate, what they do, they're there's just no way. There's no way that there is another country that the U.S. wouldn't be allied with, because a lot of... Yeah, right?
Yeah.
Because, the U.S. has allies all over the world, but, we share and we talk. But the countries that we don't know about, Russia, China, what they have going on, they don't believe that this is coming from them whatsoever. So... but unfortunately, it was only a 9-page document, so less than 10 pages, so it's really not that exciting. But yeah, basically they just took a stance of, maybe.
Yeah.
Such a bummer, right?
Lame.
Just own it. Either say yes or no. But again, I'm sure they just don't want to cause
There'll be so many implications.
Yeah, right. Of telling humans, okay, guys, listen, don't panic, but we're not alone, and we know it, and we have proof now. Now, don't freak out.
And there's nothing we could do if they did anything.
Yeah,
but I think that would be the scary implication.
Just an FYI. So we'll see.
Lose it, especially after what we've all just been through,
right? And I think
like it couldn't happen. Like, I mean, we're not ready.
I would say, but I would say if we were ever ready to be told that there are aliens, you might as well follow it up on like the most insane year.
Agreed. I think you're probably right. Just
because
give it to somebody while we're down, and then whatever, F it.
Yeah, no one will care.
Like that.
Yeah, right. Yeah. We're already at the point. Who cares? So might as well just tell us now. Be like, meh. All right, let's see what else we got to do here. So that is my nature news. I mean, nature-ish aliens. We've talked about astrobiology. Yeah. So.
Cool.
I want to believe. X-Files poster.
I'm sure there is.
There has to be.
Yeah, it's just
terrifying.
Yeah. Don't want to think about it.
Moving on.
Yeah. So, moving on, we're going to talk about fossils today.
Woohoo!
And we're going to talk about how we rely on fossils to tell us the important story of our past.
And I think this is the first of many dinosaurs, because we've talked about dinosaurs so many times.
And there's so many different things to talk about.
And this is our first official dinosaur episode.
Oh, yeah.
Yeah, okay, gotta think.
We just have tons of news.
Yeah. We really like it.
Paleontology is just constantly discovering things.
Yeah,
so,
yeah.
We're going to talk about how it helps us tell the story of our past, which, of course, like, duh, you'd kind of think, but there's lots of implications for fossils. Mm-hmm. But I'm going to start out with, what is a fossil and how does it form, to give everybody some background.
Hang in there, folks. It's way more interesting than it sounds, I promise.
Yeah. Because, of course, I'm sure most of you, when you think of a fossil, you're thinking of, like, a rock that has dinosaur bones in it. Something like that. But there are so many more fossils than just that. So what is a fossil? Actually, there's a lot of definitions, but what I found is that a fossil is the preserved remains or traces of an animal, plant, or fungi from a past geological period. So some key points there. It has to be from a past geological period. So, like,
makes sense.
Dead animal bones on the side of the road don't count as fossils. It's preserved remains or traces, and that's a big deal.
Yes, that's a huge deal.
It's not necessarily the thing. It could also be evidence of the thing. Mm-hmm. So fossils are kind of broken into two groups. There's body fossils, which are teeth, bones, shells, etc., what you normally think of. And then there's trace fossils. And that's broken into two groups, I found out.
Oh, so interesting.
There's ichnofossils, which are tracks, burrows, and coprolites, which is poop. And then there's chemofossils and biosignatures, which is chemical evidence of decomposition, even if nothing else is there. Or like metabolism evidence.
Yeah.
Kind of like what we were talking about with our astrobiology stuff.
Yeah.
How there's biosignatures. So that's what a fossil is. So how does it form? Well, I discovered... I knew a little bit about fossil formation, but not nearly enough. It's basically has to have the exact right conditions. It's how we talked about in astrobiology. We talked about the Goldilocks zone for life.
Yep.
It's kind of like that for fossils. It has to be the exact right conditions. Yes. And biggest one of those is that it needs to be a quick burial. Very fast.
Which explains...
It can't just be slow decomp.
Yeah, but that does explain why... Because you think of all the animals, okay? Of all the animals in the past, there should
why can't we find all of them?
Yeah, and that is why, because it has to be quick. Something has to happen in which it needs to be a quick burial.
Yeah, and there are a couple ways this can happen. So I'm just going to go into a couple, and then we'll keep going. So, first off... Probably what most of us think of as a fossil. It's called permineralization. So it has to do with minerals. About 99% of the fossils that we find are marine fossils, which I kind of blew my... I mean, totally makes sense once I hear it, but wouldn't...
You didn't think about it.
Fossil, I think. Yeah, is not.
Yeah.
Except for, in PA, that's all you find is, the ocean.
Ocean. I mean, same thing here in Texas. It's just... Because that's what it used to be.
Yes, it's what it used to be, and because they're able to sink to the mud and sand at the bottom, which is quickly covering them up and starts the process. Whenever we find any other type of fossil, it's usually lived near water of some sort that also buried it quickly. So that could be like a dinosaur that lived near a lake, or it could be that there was like a flood and all the sediment covered a body, but it usually has to do with water. For permineralization.
Yep.
So what happens is it's buried in sediment of some sort, and it slowly decomposes where there's almost no air. It's like locked in there. And so it really slows things down and gives things time. So as the soft bits rot away, which is gross, but okay.
The soft bits rot away.
I just think of, yeah. As the soft bits rot away, more and more sediment is piled on top, which creates pressure. And then that pressure creates rock. And that's how our sedimentary rock is made. It's just pressure, 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 slowly turning mud into rock. And so, meanwhile, water is seeping into that pocket, and it seeps into the bones and the teeth and the other hard parts, where it leaves behind minerals and, like, crystallizes the remains. Mm-hmm. And so that's the traditional fossil that you're thinking of. Like, when you see paleontologists digging up a dinosaur, it's usually, like, it's actually bone, but it's become, like, hardened bone, almost like rock itself, surrounded by rock. Okay, but that's not the only way. Carbonization is another really cool one. I really want to find out. This is, like, it's my dad's personal goal and also one of mine. I've never found a carbonization fossil.
Yeah, this would be really neat.
And it's what gives you the really awesome detail. This is the process where something is buried in sediment, but this is something that happens with plants, fish, or other soft-bodied animals like amphibians and reptiles. Mm-hmm. So as sediment builds up over the top of the decomposing remains, the pressure forces the release of carbon, which all of us have, like, we're made up of carbon. And it leaves a detailed, almost stamp-like image. So this is what you're thinking of when you think of those cool fern or fish fossils, where it's almost like a stamp or a black imprint.
Yeah, like insane detail,
you can see super detailed stuff. But again, only happens with a couple of things, and only happens under certain conditions.
I'm so jealous, because I'm in a lot of, like, fossil Facebook groups here in Texas. And when people find, like, the really good, I'm like, I hate you.
I found some cool ones in my life, but yeah, not anything crazy.
Yeah.
Like, I have found tons of marine stuff. Mm-hmm. Basic, like shells.
Yeah.
I've found trilobites. Mm-hmm. And I have a really cool sandstone snail, which I'll talk about in one of my processes.
Oh, perfect.
Okay. So that will take us to the next one, which is molds and casts. Mm-hmm. So this is when sediment fills or surrounds remains, but the original animal, plant rots away, leaving only a mold or a cast, and a cast is an imprint. So I found, like, a cast of a big snail about as big as my fist. And so there was no shell left.
Like not an ammonite, but like a snail?
Yeah, it actually looked like a snail.
Cool.
And it was in sandstone, so there was no shell left, but I popped it out, and it was like whatever was inside of that shell when it rotted away. So that's like a mold or a cast of something. And then there's replacement fossilization, which is super similar to permineralization. But this is, instead of there being any actual bone left, this is all that's left is the minerals from the water. So it looks like bones, but it really is just mineralized rock. 2 more, almost done. Organic material is considered fossils. So that's like, sometimes scientists can still find organic material in fossils, although it is rare. And it's especially hard in the above processes, but not unheard of. They have found DNA in permineralized fossils and things like that. But the following way is much better to find that, and that's through preserved remains. So that's when the entire, or at least most, of the plant, animal, or fungi is preserved nearly intact when it died. So it gives an exceptional amount of clues and information about what the creature or plant was like. It can allow DNA extraction, and it gives a snapshot of that period in time. So that's things like insects trapped in amber, tar pits that have preserved whole things, bogs, which are acidic and preserve bodies and like mummify them,
Mm-hmm.
and then ice. So these are the rarest types of fossils. It's very hard for us to find them, but when we do, it's like a jackpot because it tells you everything. Like you can even see what they've eaten.
And these are the ones that I'm going to be talking about in a little bit then
That's
too.
awesome.
Yeah.
So that is all the different types of fossilization that I could find. So, there's permineralization, where it hardens the bone. Carbonization makes a stamp. Replacement replaces the bones with minerals. Molds and casts, and then preserved remains.
I'm taking a hard deep dive back to my museum tour guide days here with this episode and rehashing. All right, so now that Laura's explained, what a fossil is and the bajillion different ways they can form, I'm going to talk to a little bit more about, which is what our message is for the episode, and it's the important stories that fossils can tell us about our past. All right, so to start off, I would say one of the major things that we can learn from fossils is how our Earth was physically moved, and plants and animals have moved as well. Animals have only existed for the last 540 million years out of the...
Just like a blink.
Yeah, it really is. It's a blink because they're estimating the Earth's origin was like in the billions of years ago. So we're just mostly going to focus on the last 540 million years or so in this episode, since that's when fossils have typically most existed. At least the cool ones anyway.
At least the cool ones.
And I say or so because plants predate animals, of course, and there are plenty of plant fossils.
And fungi predates plants.
Yep. And so there's tons of them, but again, we'll focus for this episode just on like the big fossils. Whenever we say fossils, that's what you think of. All right, so studying these early plant fossils definitely gives us a look at how the Earth once existed and how it has shifted over time. For instance, how a large portion of the U.S. was underwater, which is what Laura and I were talking about a little bit ago. Mm-hmm. If you remember back to your elementary school days, plate tectonics are a thing.
Yes, I had to write a paper on that to get into my advanced science course for high school.
Really? Interesting.
Yeah, I had to write a paper during the summertime.
That sucks.
To be able to get it.
Right, on plate tectonics.
But it was on plate tectonics. So rando.
Yeah, that is a interesting topic. Like you said, a random one. But so all of Earth's land once existed in one large island called Pangaea. All right, so as plates started to move, forming continents that we know today, we had large mountain forms, sections underwater that aren't today, and we truly wouldn't have known about any of this without fossils. Yes, rock itself and geology, of course, can tell us some aspects of history, but fossils give us a better idea of what types of plants, animals existed and where.
Right. Yeah, I think most of us could swallow it from a geologist, but I definitely think it hits at home. Mm-hmm. And right, there's so much extra to know about the conditions of that.
Oh, yeah. Goodness. So when paleontologists start to find a large number of shelled and other obvious water-dwelling creatures in an area, like they did in Texas and where Laura is, then we can start to look at, hey, this was probably once covered in water. And use geology to kind of, see boundaries and things like that. So it helps us to paint that picture. We can also see how animals have moved over time. For instance, Laura and I went down a deep rabbit hole one day.
I was wondering if this would come up.
I'll
never forget it.
Right? When we were working at the zoo together and discovered that camels originated here in North America.
Yep.
And I really think I need to start a campaign to bring back wild camels to North America, but that's besides the point.
Rewilding.
Yeah,
actually, man, that's one of the easiest.
With camels, forget the carnivores. Forget the carnivores that people want to rewild and bring back. Let's do camels. So somehow we need to make that into a t-shirt.
I guess it would be, it's
rewild the camels.
Yeah. If not camels, then just vast herds of wild llamas, because that would be the next, they're in the same family.
The next thing. So fossils do give a great timeline of how not only our Earth has moved in shape, but how animals have moved as well, because obviously we don't have camels here in North America anymore. So fossils give us a fantastic timeline of really cool events that have happened in our past. Now, let's start to break down the huge timeline of our past to further help us understand, some of the more details of what fossils can tell us. For instance, climate change. Fossils provide a lot of information about climate change. For example, by examining fossils and geology. I'm going to just keep saying geology because I feel like we have to acknowledge them.
No, I feel like they have to work closely together.
Yeah, even though that's like not... Geology is definitely not one of my stronger sciences whatsoever.
No, mine either, but I'm really interested in it.
Yeah.
Like, I think it's fascinating. I don't know much.
That's kind of how I am with genetics. I find it incredibly fascinating, but I did horribly in that class.
Right.
Horribly in that class. So anyway, by examining fossils, scientists were able to tell about the comet that struck Earth, essentially wiping out the vast majority of dinosaurs and drastically altering the Earth's atmosphere. Scientists were also able to determine what led up to the Ice Age and how the Earth was altered after it. How are they able to do this? Well, just like today, plants and animals are adapted for climate they live in. Warm weather plants typically have broad leaves with smoother edges, while plants in cold weather are more narrow with jagged edges. Two professors at Penn State University, Dr. Dana Royer and Dr. Peter Wilf, have studied this and have studied like the plants and the broad leaves and short leaves.
Yeah.
And they've determined that the reason for this is that the jagged edges on leaves have more xylem in them. Xylem is a type of transport tissue, which helps to move water from roots to the stems and sap. In the spring, when leaves, like where Laura is, in northeastern U.S., the leaves are just starting to form after a cold winter. They lose more water than leaves without teeth. The xylem then pulls up more nutrients from the roots to provide nourishment for the plants and give the plant a kickstart to their photosynthesis process. Scientists
That's why they have to lose leaves.
They have to
keep them all year, like the needles.
Yeah, they have to. So scientists who study this information today can analyze fossil records to predict what changes in climate are going to occur. Now we won't necessarily be able to predict when a comet is coming, of course.
Yeah.
I wish we could. Or the drastic increase in CO2 that humans have added to our atmosphere, which throws like a curveball in everything dating-wise. Scientists can tell But scientists can tell when we're heading for a disaster, like climate change.
Right, or like
right now.
natural cycles.
Yes.
Yeah, would be obvious.
Yeah, they can tell the natural cycles, and then just given our CO2 in the path where projected, we're screwed.
Right.
So they can see like something bad is going to happen, and that's why they're saying, "Hey, probably should look at this. It's not going to end well." So same as astrobiology, look to the past to understand the future, but I guess in this case it's look at the present to somewhat understand the past to then understand the future. Yeah. So
it's complicated.
Right? So understanding climate change is extremely important, but I don't want to dwell on that too long because then I'll end up curled up in a corner in my office under a blanket.
Totally.
So moving on. Just crying the rest of the episode.
What else can fossils tell us?
Something more cheerful. Another thing we can learn from fossils, and this is just gonna be my last because it really is like a ton, but ancient cultures, and I think we forget about this often. So yes, we do find fossilized human remains.
Yes.
Just like we can study movements of prehistoric animals, we can study movement of cultures of ancient peoples. Now, what's crazy about human fossils is we've only been able to discover about 6,000 individuals. Again, like Laura says, there needs to be very particular situations. Again, a Goldilocks zone.
Someone has to fall into a ball.
Right.
Freeze to death in ice. They have to
a flood,
die in
something.
a river.
Yeah, something catastrophic and quick. So out of 6,000 individuals from all of our past, small sample size, but sizable enough that we can learn about early humans. So some of the things we have learned are how male and female structures have changed to not only adapt to climate, but social structures, and how quickly children grew up. Years ago when scientists were first discovering humans, and I feel like many people still think this way, everyone assumes that we came from like one line of humans.
And I'm going to go into this a lot more with my
perfect.
find.
So good, because mine is just like
surface.
It's very surface. That's perfect. So that's not the case at all. Just like any other mammal, humans have changed drastically over time, given where they live. So just like any other family tree, there are numerous branches. And one early human that lived in the Eastern Hemisphere is completely different than those that lived in the Western Hemisphere.
Yeah, I definitely think that most people think it's just
one tree.
A line.
Yeah.
A line.
Yeah. It's just one line.
Us back to chimpanzees.
Yeah,
which
just
is
straight.
completely wrong.
Yeah. So it's just like any other mammal. I mean, we're a mammal, so no different. Our understanding of our past has grown so drastically that since 1974 and one of the first discoveries of early man, the branches of human evolutionary tree have more than doubled.
Oh, I'm sure.
And that to me, that's crazy. That's since 1974 is not that long ago.
That's not that long ago. The last 50 years. Yeah.
And it's more than doubled. So while there are several different types of Homo sapiens and Homo whatevers, there are completely different types of humans that once lived. And we know this all because of fossils. So
cool.
Yeah. And again, I don't know if you're going to go through just like the group of Homo sapiens and the Homo, like not all the other. No, okay, not all of them. Okay. But there are quite a few. Okay. But, and this is a big but, we have a long way to go. Oftentimes when discovering fossils, we rarely ever get an entire set. Some bones...
Yes. I think that's what a lot of people don't understand, too. It's like you find 4 pieces of the whole skeleton.
And now we've made a whole dinosaur! No, you haven't. And so... and so, scientists are literally left to just pick up the pieces and make some drastic inferences as to how and what the species looked like and lived.
Many mistakes in the past.
So many, and it wasn't
the Brontosaurus,
right?
That was my favorite dinosaur, and it didn't even it wasn't even real.
So yeah, well, in the next, okay, so there is I can't remember what they named it now, but it's the long neck.
They found something.
What we used to call the Brontosaurus. Did they completely nix that dinosaur, or is it?
I think that they might have, or they discovered a new one and then called that the Brontosaurus. But I think the skeleton that we knew as the Brontosaurus is not a dinosaur.
So think back, let's see, your 90s kids, maybe early 2000s. Anytime you thought of a Brontosaurus, very, very tall, upright neck, with a low...
Little foot.
Yeah, little foot. And that does not make sense whatsoever, because the neck... It would just be top heavy. Like there's no way it could hold its neck up. And then they're like, oh goodness, yeah, no, it can't. Like they just thought it was going to be like a giraffe. No, its neck is outright, and so its tail is level with its head and neck. So it's more of a line.
They built the skeleton.
Yeah,
but they built it based on their own assumptions, not based on how it actually is. And that's how that's how it all has to be.
Yes,
we're doing our educated guess best. Based on modern day things.
Yep. And then we just have to keep discovering and keep building on it. So it wasn't until the 90s that China discovered a dinosaur with feathers. Previous to this, all dinosaurs were drab in color and scaly like reptiles. So like Laura said earlier, a lot of paleontologists, they might find a jaw piece here, cranium piece over there. And it's just going to keep taking time before we can find more and more fossils to get a better picture.
Yeah, and I think that leads you to the thing too that that we have no, or at least that I'm aware of, we have no solid family trees. You have to skip one every now have, our common descent line is very
as far as humans go.
Things.
Yeah.
We've had to make some giant jumps from one species to another.
Especially with humans. Yeah, especially with humans, because so many of the human species we found, it literally was like one jaw piece. Yeah. And that was it.
And then just thinking what did that come from?
Yep.
We don't know what that came, you know what I mean?
And I wish scientists were more comfortable with saying, we don't know.
Yeah, because I think when you're taught stuff like that in school, it's very all right, well, we know this happened. Mm-hmm. And science is always usually very factual, but this is definitely it's theory.
Yeah.
And people have to understand it's theory.
Yeah.
To a point, although I know some people are going to come back and be like, no, there are some. And yeah, sure. But everyone has to be comfortable saying, listen, there are huge gaps.
Yeah. And I wish
we might fill them in, and we might never fill them in.
And I wish scientists were more comfortable with saying, I found something really amazing. This is going to revolutionize and change it. We just have a lot of questions left unanswered, instead of just this is what it is. This is what it has to be. So anyway, all in all, fossils tell us about our past, literally. It's really some of the only physical evidence we have to help us understand about what Earth used to be like. But just as I said, we have a long way to go, because sometimes understanding a piece of history is just that. We only have a piece, and we have to use context clues, basically context clues, to figure out the rest. So while paleontology, anthropology, and other fields may seem obscure in the information age, boy, do we have there. It's really important, and we have so much more to learn about.
Yeah, because can you imagine, like, like paleontology? I mean, people have found bones, I'm sure, since time immemorial, and that's where the stories of dragons have come from and things like that. But, like, actually, like, as a science, it's pretty new.
It is. It really is.
In the grand scheme of things.
Yeah.
And that's when we started piecing together our past.
Mm-hmm. So hopefully you guys picked up on some of that. I had to talk fast because I have a lot of information. I had a lot of information to get through, and we have so much more to go through. So hopefully, if not, go back and use your podcast app and slow it down, because I wanted to get through it all so you guys wouldn't be here for 4 hours listening to all that.
Yeah. Well, I'm going to keep on trucking with what you were just talking about.
And this should be the best parts of the episode here.
So we decided to go over what it is, how it forms, why it's important, and now it's the important finds that we found in the past.
The crazy things.
Some highlights.
Yes.
So my one highlight is Lucy, who goes right along with what Katy was saying. So here we go. Some of you have probably heard of Lucy before. She was a very early hominin or hominid, depending on how you say it, aka one of our ancestors, that helped us rewrite our knowledge of human history. So that date of 1974, that's where this comes from. So her remains were discovered back in 1974 by Donald Johansson and Tom Gray in Ethiopia. And here's what kills me, okay? It was a complete accident.
Yes. Yeah, they weren't looking.
I was so like, what?
Yeah.
Some people have all the freaking luck. They were literally taking a shortcut through a gorge and noticed some bones sticking out of the ground.
And then they just made one of the largest scientific discoveries of our time.
Totally. I was like, man. So they decided to call her Lucy because while they were celebrating, like that night about finding her, they were playing the song Lucy in the Sky with Diamonds by the Beatles, because, it's the 70s.
So why not?
So they were like, why not?
Yeah.
So she's Lucy, named for the Beatles song. So we know that she was a hominin or hominid because she could walk upright, and that's basically like the key, like that's what a hominid is.
Are you going to go in?
Bipedal.
Are you going to go into how we can tell?
A little,
okay.
Vaguely.
Okay.
So I was just going to say, but feel free to fill in more. Okay. Scientists can tell this from looking at leg bones, pelvis, and spine, all which have characteristics that are made for walking upright without it being painful. So, like, your leg bones are longer, your spine is more, like, curved in a certain way, your pelvis is, it's all made so that you can carry weight upright, not on all fours.
Yeah, I mean, in a way, now, I mean, this is where scientists do get it wrong. In a way, it is like a puzzle piece. Sometimes, you have to look at the bones that you're given. Okay, is this going to fit here? Does this make sense here? Yes or no? Okay, yes, right. Okay, but did it really fit this way? Which goes back to the Brontosaurus example.
Yeah, I think that definitely, like, paleontology is so complicated because I think you also have to be very familiar with anatomy and physiology.
So familiar. Like,
and geology.
Yeah.
And, like, it's like a,
It's way more complex than I think what a lot of people...
digging up bones.
Yeah, and I don't think people really give it the true... like, people always think, oh, how hard physics is and things like that, but I don't think people realize how tough paleontology can be.
Yeah, you'd have to be a creative thinker and a scientist.
Yeah.
Which is not always an easy combo.
Yeah, right? Opposite sides of your brain sometimes.
Yeah. So, they decided, scientists determined that Lucy was a species that's called Australopithecus afarensis. And there are lots of other species of Australopithecus, which is not Homo sapien, but is an ancestor. So scientists have never positively determined the cause of Lucy's death for sure, because you can only tell so much from bones, They don't have a body to work off of. She was not an intact, it is just bone. So either permineralization or replacement. But they did find a carnivore tooth puncture in her pubic bone.
Interesting.
It could have caused her death.
Yeah.
They're not sure.
Or it could have just been a childhood mauling of an animal.
Right. Exactly. Yeah. They just, all they know is that it was before she died because they can see, like, healing. At least a little bit. not like after, not gnawed on after the fact. So we can tell from Lucy's skeleton, which I always think is cool. You can tell a lot of things from a skeleton. We know that she was young, but she was full grown, so she was a young adult. We know that she was female because of how small she was compared to other species of this that they found. And that she lived
and you can also, a lot of times with the females, you can tell pelvic structure.
Right. And like rib cage stuff, I know too, is sometimes. So we can tell that, and from carbon dating and things, we know that she lived around 3.18 million years ago.
Mind-blowing.
Yeah. So she would have been about 3.5 feet tall, and again, she was full grown.
So about my size.
You're not that tiny. And she weighed around 60 to 65 pounds, so she was just a little gal. But full grown. So why was this a significant find? And here's where it gets awesome, because we really did learn a lot from Lucy, and why, like, we say that she rewrote our understanding of humans. So at the time, she was the oldest and most complete hominid ever found. Okay, so 3.18, we were like, whoa, this is so old. And let me tell you what I mean by most complete. Most complete is 40%.
Yeah, which it was
so we found 40% of Lucy's skeleton. And made a lot of conclusions, thankfully. 40% is pretty significant.
Yeah,
I'm sure
it's
you
better.
can tell a lot.
That's better than most fossil finds. I don't know if that stat is out there. Go ahead and keep talking. I'm gonna see.
No, yeah, I would.
It's got to be so small.
So this helped us to close the gap a bit between modern day humans and the ancestor we share with chimpanzees. So here's where, the debate really gets heated. If you say evolution happens and we are descended from chimps, and people are like, well, why are there still chimps if there's us, and things like that. Okay, so think about this. Like a dog and a wolf, a dog isn't necessarily descended from a certain breed of canine.
Mm-hmm.
It might be on the same level of a family tree. Imagine all these branches. Yep. At one point, yes, there was a common ancestor. But guess what? That common ancestor was not a chimpanzee. The chimpanzee's grandpa and our ancestor's grandpa could have been the same. You know what I mean? Like, it's kind of like that. Like, it's, we did not come from chimpanzees. They're in a completely separate line. But we did share an ancestor. But the crazy thing is that they've just recently done some DNA tests. And they think that our closest common ancestor was as far back as 13 million years ago. So that's about 10 million years further back than Lucy.
Mm-hmm.
So we still have a big gap to fill.
Yeah.
And of course that means Lucy was way closer to us than she was to chimpanzees.
Yes.
Which is interesting because we also did find some things about like Lucy's skeleton has a lot of things in common. Like they would say it was more ape-like. Only because of things like having
3.5 foot height.
Besides height. Yeah. They specifically mentioned her skull and teeth and arms. Like her arm bones were really long. Her teeth and skull look very ape compared to our skull. But again, think about, and that was after 10 million years of descent.
Yeah.
So anyway, another really important, so the important thing was, one, it got us so much closer at the time to a common ancestor. The other big thing was that Lucy showed us that bipedalism came before large brain size, which I thought was fascinating.
Yeah.
So we walked upright a long time before our brains got bigger, like by 1 million years, literally 1 million years.
Can you imagine a tiny brain, like lower functioning? Like, why am I standing? Like, why?
Yeah.
Like they just don't know.
And there's multiple theories as to how and why this happened. So they
could
because of her
they just could. Yeah.
Because she had so many ape-like characteristics, they think that Australopithecus probably spent a lot of time in the trees. So maybe bipedalism actually is an arboreal trait for walking along branches quickly.
Would make sense. Yeah, that would make sense.
If not, another theory many scientists believe is that it was an essential a way to combat the changes in our diet. And I've seen a lot of documentaries where this is the one that they're toting as probably the most likely. So at the time of this happening, again, climate change and things like that, the environment was changing. So there was less trees. They couldn't, arboreal species had to come down more. And because of that, their diet had to change. So before that, they think that, like, before Lucy's species, they were probably mostly eating fruit. But this allowed them to eat more grasses and possibly meat and, like, hunt and things like this. And we know what they were eating because they have found food remains in the fossilized teeth of some of these
way
hominids.
Before floss existed.
Right. And so, actually, like, if you don't like flossing, you can just hope that you'll become fossilized and it'll all be...
Yeah. I'm doing this for science.
So that's, like, the two big things. It's how much we learned from her, the bipedalism, and then a couple other cool things is they're pretty sure, well, it's highly debated. They think Lucy and her relatives may have used tools because they have found in a similar geological period.
Yeah. Again,
so possibly tool use.
Yeah.
But hard to know. They also believed that Katy was saying we can tell a lot about ancient cultures, so we think that Lucy lived in probably a small social group, and probably one that was male-dominated. Why that? Because the females were so much smaller, and in, like, a male-dominated society, that's usually, like,
with several
like
species.
A promiscuous society, that the male is usually much larger to compete for females, yada, yada, yada. So we can extrapolate some things from that. It's also believed that she matured way faster than we do. So she was a fully grown adult, be it young, but they think that she, based on, like, her bones, I don't know how they know this, but they're pretty sure she died when she was 12. But she was grown up. It
has to do with a lot of times it has to do with the closing of the growth plates. Like in the spine and around your body. So that's normally how I can tell.
Tracks more for, like, of course apes mature much faster than we do because their lifespans aren't as long. So, again, Lucy was grown up at 12.
Well, and they have to, too. I mean, human civilization, as we kind of know it today, we have a pretty easy...
even now,
we have a very easy... we have a very easy lifestyle. So, whereas... chimps, apes of any sort, they're quite literally forced to grow up way faster than needed.
And that's what I think is kind of fascinating, because although humans were forced to grow up, like, mentally, like, and there are certain traits of us, like, yes, of course, most of us girls could probably have babies when we're 12. But a lot of the rest of our body, like our brains, don't finish developing till 25. So there's definitely something about,
I mean, that's why they say that it's better that you marry and make a decision, big life-altering decisions after you're 27.
Yeah.
I got married at 22.
My mom specifically told me I shouldn't get married before age 25. For years. Like,
Oops.
She was like, don't do it. I got married at 25 or 26.
We got married at 22. We were young.
You'll be fine.
10 years later, here we are.
Yeah.
Can't be that bad.
And then last but not least, so also at the time, she was only one of 7 hominins known. So we'd only found 7 different species at the time. And just like Katy was saying, it's exploded because now we know of at least 20 different species of hominids.
Crazy.
But unfortunately, we still don't know which ones are our direct ancestors and which are only related. Which I think is so crazy. Yeah. That, like, we have no answers. We're getting the pieces still. And we may never find out, but I really hope we do.
Yeah.
It'd be kind of cool.
That would be really neat. Alrighty. My important fossil find that I'm going to discuss is Yucca in Layuba, the mammoths.
Woo!
I'm really excited for this one. So when I did work at a museum and it was a tour guide, talking about mammoths was, to me, it was just mind-blowing. And this stood out because this is when I learned about mammoths. And and their unique case in how we find mammoth fossilized today.
Just the preserved remains is so fascinating.
It just stood out to me. So hopefully, if we didn't
bog people,
bog people. If we didn't blow your mind yet, one, go look up pause and go look up bog people.
Yeah.
But two, get ready to brace yourself for some of this mammoth stuff. All right. So a little mammoth background. Mammoths lived from about 5 million years ago to just about 3,500 years ago.
Which is so recent. We were so close to being able to see mammoths.
So we're in 2021. So these creatures were walking around in about 1500 BCE, which, to put into context, mammoths were around after the pyramids in Giza were built.
What?
Yeah, is that right?
What?
Yeah, so while
I thought it was like 10,000 BC or something.
No,
wow.
well, most went extinct about 10,000 years ago, so it would be about 8,000 BC. But there was a lot, and that was most of them, but there was a population that lived north of Russia that got stuck on this island and stuff, and those, they like funneled, I mean, they eventually funneled, and that's what killed them, but anyway, and I'll talk about that in a second. But yeah, so that population lived to about 3,500 years ago, so 1,500 BC. Whoa. So they are closer to us timeline than the pyramids of Giza by about 1,000 years.
Whoa.
So not a little bit of time. Yeah, a lot of time. So like I said, most mammoths, though, went extinct around 10,000 years ago. We know humans did coexist with mammoths because, although rare, we have dug up mammoth bones with spear marks in them, noting that they were sometimes hunted. Mammoths have seemed to go extinct due to a variety of reasons, but the last have just had horrible genetics. So I'm talking about the ones that were on the island.
You can't live on an island forever
right?
Without getting seriously inbred.
Well, they were prone to severe diabetes, low sperm count, and so much more. So they were eventually going to die out. I mean,
imagine somebody finding those guys and just being like, ah!
Yeah.
They're like all freaks.
Yeah. But 8 legs.
Yeah. They're missing a trunk.
Yeah.
Who knows?
So the word mammoth comes from 2 words in the Estonian language, which is ma, which means earth, and mut, which means mole. Which, yes, mole. Yes, earth mole. So in Estonia, which is a country, farmers found gigantic bones in their field. They thought that the bones belonged to a huge burrowing animal.
My God.
Which, if you've ever seen,
I love that conclusion.
Right? Huge.
I found it in the ground. It
must be a mole.
A burrowing animal.
Must be a mole. And if you've ever seen a mammoth bone, if you haven't, go to your nearest natural history museum. But they're not small. So that would have been a heck of a mole. Like a heck of a size mole.
A heck of a mole.
Because it's huge.
Now, Josh, you also need to draw that. Please draw like a mammoth popping out of a mole.
A mole.
But a giant one. A mammoth-sized mole.
I mean,
it's so cute.
To be fair, maybe they always just found dead babies. You know what I mean? Like, maybe they just...
What?
Like, dead mammoth babies, not dead human...
Oh. I was so thrown away by that phrase. I was like...
Dead mammoth babies. Maybe they just always found dead mammoth... You know, because they would be smaller.
Oh,
because there's no way a huge mammoth bone, they're like, surely this must be a mole. Because they're huge.
What time period were these found in?
You figure they died out 10,000 years ago.
No. But when did the Estonians find them?
I believe it was somewhere between 15,000 years to the 3,500 years ago.
Oh, okay. Well, then, yeah, I totally believe they could have thought it was a mole. I mean, they thought dinosaur bones were dragons. So,
true.
Like, cool.
I mean, I wish they were dragons. Let's bring back dragons, too.
They kind of are.
While we're bringing back camels, we'll bring back dragons, too. I wish.
Yeah.
All right, so mammoths are 10 to 15 feet in height, and the largest weighing about 6 tons. Entire fossilized skeletons of mammoths have been found, and one of the largest skeletons ever found was a Colombian mammoth named Zed, which was unearthed from under an LA department store.
Oh, snap. What a fun find.
Right? What makes mammoths so unique is giving their recent proximity to humans and the most notable mammoth, the woolly mammoth, living in such cold climates, which is like Serbia, Russia. Scientists have found entire bodies frozen in the ground. I'm talking fur, stomach contents, and all.
So cool.
There are no guessing games with mammoths, like feathers or no feathers questions with dinosaurs.
Right.
Because
you find the whole thing. There you go.
It's there. And so too, just to throw this out there, so whenever most people think of mammoth, they think of the woolly mammoth. However, there were tons of mammoths all over the world, that then gave rise to various elephant species.
Right.
So whenever you think of woolly mammoth, not all mammoths looked like the woolly mammoth. A lot of them looked like larger elephants, hairier elephants.
Weird. I remember in my dinosaur book as a kid, like there were like these elephants with like crazy looking shovel teeth and like weird stuff.
Yeah, and so what I'm going to be talking about is our woolly mammoths, because again, found a nice, completely preserved, and so that's what I'm going to be talking about. Are those completely preserved, mummified ones that we found?
Yeah.
In comes Lauba. Lauba was found by a reindeer herder and his 2 sons in 2007 on the bank of a river. They estimate her age to be about 41,000 years ago.
Whoa.
However, her death occurred when she was about 30 days old.
Oh,
right.
Oh, right. I forgot this was a baby.
Dead babies. So due to
my mom, speaking of the ice, my mom is constantly talking about in the news. Apparently, so many of these glaciers are melting. The permafrost is melting now, and they're finding such cool stuff, like human wise.
Yeah, which
as the ice is going down too.
I'd like to say that's great, but yeah, that's really horrible.
Yeah.
So,
all right, anyway, keep going.
Due to the way that Lauba died, which scientists believe was snorting up butter-like clay into her trunk, having it...
What? What a dumb way to die.
Mammoth? I mean, she was only 30 days old.
Aspirating clay?
Yeah, pretty much. And it just got stuck in her trunk, suffocated, and she was basically suffocated on the clay. The bacteria that found her essentially pickled her like one of Grandma's cucumbers, making her carcass unedible to any would-be scavengers. But again, because we said it was quick, and that's why they think it was like mud, she probably got stuck in the mud, whether it was they were crossing this area or what, who knows. Yeah. But we know it happened quick. And we do know that it was found in her, like that she had stored it up the clay, because we found the whole thing, and they found the clay in the trunk. So what I'm talking about in this is not scientists inferring, because we have the whole thing, and like I said earlier,
it's like an autopsy.
Yes, it really was an autopsy. Yeah. So what's fascinating about Lauba, except for everything that I just said, like I said before, she is perfectly preserved inside and out. When scientists examined her stomach contents, they even found milk from her mother in there.
Oh, that's so sad.
Yep.
Her mom was probably heartbroken.
Finding food in mammoth stomachs is fairly common nowadays, which is what used to sound very outlandish when it first started. Scientists have been able to tell precisely what mammoths eat because it's still in there. It's in there.
Yeah, and that would let you know the climate,
everything.
The plant life. Yeah,
everything. So with Lauba, scientists were also able to find fecal matter in her intestines. So not only do we have a preserved specimen from 41,000 years ago, wrap your mind around that for a second. Like that's 41,000 years ago, and it's right there in front of you. Mind blowing.
Right, like the day it died. Almost.
Yes, pretty much. But anything in her stomach is also perfectly preserved. So while finding these creatures are an amazing advancement for science, sometimes finding such creatures can lead to questionable actions.
Oh, I'm sure.
Right.
There are some scary implications for preserved specimens, too. Like, if everything's preserved, so could the bacteria be.
Oh, yes.
And the diseases that killed them.
Mm-hmm.
So as this permafrost melts, who knows what sicknesses we're going to start getting. Terrifying!
Or, like in the next one, I think it's pronounced yucca, Yuka. So this one was also another young mammoth found in the Siberian permafrost, is about 28,000 years ago, which is what they dated her. So much younger than Lyuba, but she was believed to be...
Wait. 14, I thought, how old was...
41,000 years ago.
41. Gotcha.
41,000. And this was predicted to be about 28,000 years ago.
Gotcha.
But she's believed to be about 6 to 8 years old at her time of death. Discovered in 2010, Yucca was believed to have died in a shallow pond or a lake, given that, what was found in proximity to her. Yeah. Yucca is the most perfectly preserved mammoth mummy in the world. Even better off than Yayuba, and we thought that was like amazing. 3 years later, here comes the second one.
But again, here's the water coming into play.
Yep.
Too.
Every time.
Helped a lot. Yeah.
So Wayuka also has a fantastically preserved stomach and fantastic tissue samples. So, what do scientists do with Ryuka? Scientists in Japan have gone full Jurassic Park on us.
Yep.
Which, not fully, but they're getting there. So, scientists have extracted tissue from her bone marrow and muscle and injected it into mice germ cells. Now, germ cells, I'm talking about reproductive cells, not like cough germ cells, actual reproductive germ cells. So once in the germ cells, the mammoth cells started to show signs of cellular activities.
Which is insane! You can resurrect dead tissue that's been dead for that long.
So, as they were in those germ cells, they started showing activity that they normally would right before a cell would start to divide. So they are on the brink of making it happen.
Right, making a mammoth from a test tube.
Mm-hmm. And I'm not talking about it just started wiggling or moving. No, it actually started to reproduce sections which needed for cell division.
Gotcha.
Which is so it was actively getting close. It's not just oh my goodness, I think it's going to start to divide and it's just sitting there wiggling. No, it was creating the steps to get there to cellular division, which is nuts. So what does Yayuka have to do with fossils telling us an important story of our past? I brought it up because while Lyuba does tell us about the past, Ryuka is being used to understand science in a whole new way. Is it good? Is it bad? As we come across more and more soft tissues in fossils, like scientists did in 2005, when they found collagen fibers in a T-Rex bone, we're going to have to answer a lot of ethics questions.
Right, just because we can, should we?
Exactly. And since
that's always the science question.
And since we've all seen Jurassic Park, minus Kim, life always finds a way. And scientists are going to have to draw a line, somewhere when our story of the past stays in the past, or will it be used to shape the future?
Right. No, that's the implications are insane. I feel like there's no way you can possibly think it all out. Because even for example,
there are people that have but there are also people that have good intentions and people who have purposely bad intentions.
Well, I was just going to bring up let's just nowadays, let's say, we have decided, what could really help take care of this pest is this other insect from the other part of the world.
Yeah, right.
So we're gonna release them. They're gonna kill all the pests and problem fixed.
Nope.
It doesn't happen.
Not that easy.
And then we get a second problem. So I can only imagine
T-Rex
introducing a species from not just another area in the world,
another time.
Mm-hmm. Yeah, we have no idea what that would be like, and the parasites that it could bring, and the disease, and it's the same with plants. They have resurrected dead flowers.
Yeah,
that's already happened. But should we grow them?
But it's the same thing as okay, so you don't know, like you said with the mammoths, it's not essentially an autopsy, and they take all the precautions. I mean, they're in suits hazmat, you know what I mean, the whole white suits and everything, but you don't know if it died from a bacteria or parasite. So you're cutting into a stomach, you're cutting into a species, and who knows? Because everybody has certain bacteria in guts. Totally. So you do not know what you're releasing.
And it might not even have been what killed it.
Correct.
But it could be deadly to us now.
Exactly.
Because it's been so long.
Yeah.
Yeah. I would not want to cut into something that hadn't been seen the light of day for millions of years.
Yeah. Or 41,000 years ago. Yeah, that's terrifying. Yeah. So, again, fossils of any variety, whether it's humans or mammoths or just traditional finding collagen fibers in T-Rex bones, Fossils, they do tell us an important part of our past, and they're probably going to continue to shape our future as we discover more.
Totally.
All right, that's all we have for you guys today. Be sure to check
us. Exploded some minds.
Hopefully you guys learned something. So come talk to us. I need to put up the Discord link. I need to remember that. Make sure you guys go to our social media and check out our Discord page where you can talk to us and other nature nerd-minded people. So we made that available.
Join the Nature Nerd Nation.
Yes, definitely do that. The NNN. And follow us on our social media, Instagram, Twitter, at FTLON Podcast. And we will talk to you then.
Yep, talk to you guys soon. Bye.